Okay, so for number one, so what you want to do is keep the 36 where it is. Now they didn't put parentheses here. And move the 6 to the other side, make it 6 squared. Now, is that a true statement?
Yes.
Yes. Okay, try 2, 3, 4 next. I'll give you guys like 30 seconds. Should be pretty fast. Try 2, 3, 4 next. I'll do it as well. So for 2, keep the 17 where it is, move the 289. 3, keep the 1 over 196 where it is, move the 14. Number 4, keep the 81 where it is, move the 3. I'll give you guys about like. Well, yeah, no, you're just rewriting an exponential form. Oh, you need one. Yeah, sorry about that. You just got here. Here we go. Oh, you have much shorter hair in this picture. Is this from middle school or freshman year? Okay. Okay. I wonder why they didn't update the photos. Okay, here we go. You should get that. Okay. So, guys, let's focus. 17 equals 289 to the 1/2 power. That's a square root. If you were to square 289, you get 17. 1 over 196 is 14 to the negative 2 power. If you square 14, you get 196 with negative exponent puts on the bottom, right? Whoops. 81 equals 3 to the 4. 3, 9, 27, 81. Multiply 3 4 times, you get 81. Okay, that's how you rewrite. I'm definitely asking a question like that in the homework quiz, making sure you can rewrite from log form to exponential form. All right, next up. Rewrite from exponential to logarithmic. So go back the other way. All right, if we go back the other way, here's what happens. What's your base for number 5?
64.
So you can do log base 64, and you swap the 1/2 and the 8. That one's a little more strange, but if you think about it, what we did prior, 64 to the 1/2 does equal 8. 64 rooted is 8. So that's how you rewrite it. Try it for 6, 7, 8 now. So you want to write the same way. Yeah, you should. You should. Yeah. Yeah, that'd be a good idea. Okay, I'll do the next 3 while I freeze my screen. Here we go.
Bro, how much cooler the logos were. Literally every single one of them just like separate. That's style. It's not showing that exactly. But no, have you seen the jerseys? The jerseys.
How do you get log again?
It's
Alpha window. But you have to be able to do this without a calculator though.
No, I haven't checked.
Just check
that.
that. Okay. All right, guys, let's come back. All right. So, guys, quiet, please. Thank you. So here's the deal. Excuse me. So the base is 12 for number 6. So log base 12, 144 equals 2. The base is 9. Log base 9 of this is 92. Do 9 to negative 2. 9 squared 1 is 81. Flip it, you get that. Here, 12 squared, 144, 12 times 12. And that's just a fraction, right? Not a big deal. But 112 squared gets you that. Okay. All right, now this is where it gets a little funky because there's more letters. Because we could verify 1 through 8. So you have to have a little more faith that you know the shifting of letters properly, right? So I'll do a couple of these here. I'll do 9 and 10. How have you guys do 11, 14? 11 through 14. Okay, so what What's going to stay on the left side for number 9? And what do I move to the other side? U to what power? Perfect. See, it's just a shifting of things, right? It's just a shifting of things. What stays on the left side for number 10? U. And I'll be kind of honest with you guys. You might want to be very OCD about this a little bit. It's okay to be OCD because when I was doing this many years ago, I always wanted to put the log on the left side and then put the exponent on the other side when I was shifting things around, just so I can kind of see the movement. I mean, now as you've done, I've done this a long time, I can kind of do some different ways, but it helps keep the log on the left side, and then we shift, move the exponent to the right side. If that helps you to kind of see the movement, so things. Yeah.
Is number 11, 7 over 4?
No. What stays on the left side?
Oh, X.
X, yes. Okay, guys, try 11 through 14. Oh, crap. Okay. Hopefully you got this. Okay, again. Keep the X on the left side, send force to the Y. B equals 2 to the U. B equals U to negative 16. X equals Y to negative 8. All right, good. Okay, now let's go back the other way. All right. I'll do 15, 16, have you guys do 17 to 20. And at that point, then I'm going to have you guys then do 20 to 30 in your table groups. Then I think you can handle it. All right, 17. So let me do 15 and 16. All right. So what's your base for here? U. And a negative 14 and V switch. Same thing here. Log base 8 of A. Because what you're doing is you're telling yourself, well, this raised that power. That's what log ever is. Like, forget about the negative 14 for now. When you see this, if you just saw log base U of B in parentheses, you just ask yourself, what would I raise U to get to B? Oh, I raise U to negative 14 to get to B. Okay, fine. But here, okay, what would I raise 8 to get to A? Oh, I raise it to the B power. 8 to the B power equals A. So always, when you have a log, just in general, it's really just saying X equals B to some power. That's all it ever is. Because when you have this, and you're trying to solve for the exponent as an unknown, you have to use a log to do that. That's what log does for us. It helps us solve for exponents and unknown equations that have exponents. Okay. Try 17, 18, 19, 20. Remember, your base is 1/5 or 6 or 9 or B. Rewrite just like I did for 15 and 16. I'll freeze the screen again. All right, here we go for, excuse me, 17, 18, 19, 20. So log base 1/5 of Y equals X, log base 6 of X equals Y, log base 10 of X equals Y. log base b of 123 equals a. All right. We're cool. Okay, okay. Now in your table groups or on your own, try 21 through 30. What I would suggest that you do is maybe set each of these equal to x and solve for x. Like think of it like this: 64 equals 4 to the x power. And then figure out x is. If you need to use a calculator, it's okay. I mean, I would be somewhat okay with a 4-function calculator for problems like these. But, you know, on a test, well, what would you multiply 4 to get? So how many times do you multiply 4 to get 64? Well, 4 times 4 is 16. And then times 4 again. What do you think 16 times? Well, 16 times 4 gets us 64. So let me put on the board here. So 4 times 4 times 4.
Oh, 3 times.
3 times. Get 64. Correct. Yes. Okay. Try the other ones. Okay, so tell me, okay, so tell me when you shift it, what happens? 4 equals what? Good. Yes. Okay. Now, because it's a lower number, I know you're not multiplying 64 a bunch of times to get 4. So it's a rooting situation. So what root would you raise 64 to get the 4? Or ask yourself this question: how many times did I multiply 4 to get 64? 3. But it's a root. It's a root. So instead of 3, you're going to say 1/3. As a fraction, yes, you're going to say 1/3.
So you set all of them to equal to that.
That's what I like to do usually, or any letter you want, your choice. Yeah.
Why not? I didn't do that.
Okay, so I know it's a little without a 4-function, it can be a little tricky. So you keep 1/2/16 on the left side equals 6 to the x power. Now, because you see a fraction, instantly I know I should have a negative exponent. Okay. Now 6 times 6 is what? 36. Now I know it's kind of hard to do in your head, but I suspect if I multiply 36 by 6 again, it's probably gonna be pretty close to 216. If I'm not giving a calculator, I'm pretty. If you try it, what's 36 times 6? Right. So you just have to have some faith that it will be okay, even though you may not be able to know 36 times 6 in your head. I mean, if you want to write it out, you could. That takes a while to do the multiplication all written out, but it will be -3. So the fact that it's a fraction, that's why we have a negative exponent. And of course, 6 multiplied 3 times gets me to 216. So I'm going to report my answer as -3. That's what I'm going to do. Yeah, you guys have seen some of the funky ones. This is good. I like it. All right, let's just keep going here. Yeah, Jazz, go ahead. Correct. Yes. Yes. Like in the case of, well, 23 is an easy one. That's 2. That's easy. All right. Yeah, so let's talk about 24, Jasmine. Like how this one. 1/243 equals 3 to the x. Close. So 3, 9, 27. 27 times 3 is 81. And then 5, yes. You went a little too far. So that's -5. That's me 2. Oh yeah, 100%. Yeah, on the quiz today. I'll let you guys use 4-function if you want one.
Yes.
Today's quiz should be pretty manageable without a calculator. I don't think you need one. I think you'll be fine. Fractions.
No, it's like 6.
I think you can. How would you root the 64 to get 4? Like, basically, how many times do you multiply 4 to get 64? 3. But because you're going in reverse, it's 1/3. Yeah. Yeah, thanks, Shrug. I'd agree. And that's going to be 3. No, 1/3. 27 is just like 29. Okay. Yeah, we're gonna do that next. Okay, before I move on and finish this off and have you guys start the homework quiz. Any questions on 20 to 30? 27, by the way, is a really weird one. I won't do this on a test. I think that's a little too harsh. Yeah, I will. But 27 is just like 29. You're cube rooting because you're going from a bigger number to a smaller number, and you have to ask yourself how many times I multiply 7 to get to 343. You're not gonna have to multiply 7 like 20 times. That's crazy, right? 7 times 7 is 49. If you multiply 7 one more time, you have faith that's gonna be 343. And it will be. It's pretty darn close. It's like saying 50 times 7, right? 50 is close to 49. 50 times 7 is 350. It's close enough, right? Now for 24. So base 3, right? 3 to the x equals 243. So just use your fingers. 3, 9, 27. Times by 3 again will be 81. Get it? And then one more time is 243. But because it's a fraction, that's why it's negative 5. Right. So when you go from the base, a whole number base to a fraction, you got a negative exponent. But if you're going to just a larger whole number to a smaller whole number, then you're going to be getting like a fraction exponent. That's why we spend all this time fraction exponents as well last semester. We'll be on the 28th, I think. The Wednesday. Yeah, the Wednesday, yeah. So next week we'll wrap up the unit. We'll have a day of review before that. So, and next week we're back to a 4-day week, back to the 75-minute classes. Just so you know. John, go ahead. Sure. Reggie, you had a question? Yeah. Yeah, well, we'll see. Okay, then we're gonna move on to the last 4 afterwards. Oh, I'll do it. Yeah, last 4. I'll do it right now. I'll do it right after you guys. All right. Okay, last 4, guys, and then we'll do the homework quiz. Here we go. You guys doing great. All right, so okay, these are kind of weird. What I'm going to do is set this equal to x. And I'm going to do log. Actually, here's let me redo this problem. Let me rewrite it in different colors. Okay, guys, look at stop. Thanks. All right, let's color now because I got this nice, beautiful projector. I can color code with different contrasts that you guys can see. Okay, it's going to take me a little while because I'm going to be switching colors frequently, but it's for your benefit. Okay, actually, let's just set equal to, say, the letter Y. Here we go. Okay, now we know this. This is the true reason why these problems work the way they do. Because I would feel like I've done you guys a disservice if I just say, oh, just cross stuff off, and because you're not technically crossing stuff off. Actually, give me a sec here. Let's go back to X. Sorry, let's go back to X. My apologies. My apologies. Let's here we go.
Good answer. Yeah. To be like truly.
Okay. Actually, hold on. You guys quiet? I'm almost done here. Thank you. Here we go. Okay. Oh, let me erase this, sorry. All right. So let's be present to this, right? So in pink, I put b. B to the y equals x. So the y shifts down, the b becomes a base, and you have that, right? So if you think of it in the same regard, what's in y's position right now? Over here. That whole log thing, right? So if I shift that down and think like this, log base 12. You could actually, but let's say you can't. Let's say I get something really weird. Let's say you can't. Yeah, no, you're 100% correct. You can. It's going to equal 12. Actually, hold on a sec. My apologies. Let me rewrite it one more time. So log base 12. I meant to write like this. My apologies. Here we go. Okay, now I got it. Okay, hopefully you see what I just did. So, you see how the 12 became the base? Guys, focus please. See the 12 becomes the base, x becomes the input, and that exponent becomes on the other side. Just like I did over here, right? So see how like b becomes that y goes over there, x is just the same exact thing I'm doing. So what's in x's position? 144. So whenever you see this, whenever the base of the log and the base of the exponent are the same, it's really just the exponent. I mean, some people do this. That's not good form. I don't really want to teach it that way. It's because when you shift things around, you wind up getting x equaling 144. So you could just do it like that. Like for 32, if I follow the same procedure, what's this whole thing gonna equal? Right.
Why can't you say about it just crossing off the two of those?
Because it's not division, that's why. Like multiplication and division, like when we have like.
But technically, like not.
How about this? How about yes? They undo each other. They undo each other. Yes, you can think like that. So let me clear this because it's getting a little busy. So think like this: if this equals y, then log base x of y equals log base x of 72. What does y have to be to make that true?
2.
There you go. That's why it works. So for this one, for 34, I know you guys are stuck on this one. So that was 144. That was 17. Now, you guys are stuck in this one. So log base 9 of y, if I said it's equal to y, let's say, of y equals log base 3 of 20. But it's weird because the bases are different, right? So we're a little lost. So what I would do instead, before I do the shift, rewrite this as 3 squared. You would agree with that 9 is 3 squared, right? Okay, I'm not doing this in the homework quiz, by the way. 34 is a little too tricky. But then you can rearrange the exponents like this. There's no harm in doing that because what if I had, for example, what if I have 4 squared, then cubed? It's the same thing as 4 cubed, then squared. It's the same exact thing. So by changing the base of 9 to 3 squared, and swapping the exponents, what did I get, John?
What?
Yes. Yes, you get 400. Yes. That's right. Because that's 20, and you're doing 20 squared afterwards. Exactly. That's 20.
The show.
Oh,
because
because
they
they squared.
cancel.
And these will cancel, right? Those they undo each other. They undo each other. That's what happens.
Wait, but why would the square go to the whole thing? Why would the square?
Because we have up here, right? This is like if I did 16 cubed, it's the same thing as 64 squared. Because if I just swap these two, who cares? Because it's still 2 times 3 and 3 times 2. It doesn't matter. Right? Because remember when you have properties of exponents, when you raise the power to the power, you multiply the exponent. So if I were to swap these two positions, it's still the same thing. It won't matter.
Is this easier?
Could I do it either way?
What do you mean either way? I don't know what's the other way.
Is this easier?
Oh, wait. No.
I mean, just writing it so like that, and then the X.
Um,
equals 20.
Log base 9x. Not like this one, no.
Doesn't look X.
Hold on. That seems weird to me.
Because 3 is
So you said log base 9. It's not quite correct. Let's revisit this when we get next week when we do propers vlogs, or the next unit, I guess. All right, I think we're good. Let's do the homework quiz. After homework quiz, you guys can do homework, which is homework number 5. What was that? Yeah, it's 400. Because what I did was I changed 9 to 3 squared, and then I swapped these two. And then when I worked this out, that was 20. Because these are the same.
Okay.
And I did 20 squares. 20 times 20 is 400. That's what I did. Yeah, that one's a little bit more. That's like more of an honors level question, I'd say. I care more about 31, 32, 33 than 34. So. All right, let's do the homework quiz. All right, it's five questions. Each one's worth 1 point. You have to do quite the outside, you know? So you've got like a bagel and.
Oh, that was a long time ago. Like, I'm yeah. I they sent me email, I just do my paper, which I still didn't do. What do that? It doesn't have paper. and
Don't rush your work.
No
calculator, please. You need one.
I've moved on, so we started with the first one. I don't know. So,
Big one over a sec. Flip it.
This
It's close. No, that's what it's great. Is it the what?
you idiot. Come on.
Yeah, and afterwards, you guys can start homework, which is homework 5. Oh, hold on. Yeah, I know. Wait, hold on. Thanks. You guys, please be quiet so other people can work. Thank you. Thanks.
Answer for these like that.
Yeah, totally 100%. Yes. Good.
I'll get one.
Sure. Yeah. And again, homework will be homework 5. Oh, let me stop recording.